Okay, I'm going to see how this works. So this is me trying to do some notes myself while recording a piece of paper that is on my kitchen counter. So anyway, here goes 9-1, translations, which I like to call slides. So some vocabulary that you need to know for the whole kind of transformations chapter 9 is rigid motion. That's the idea that the translated image keeps its exact size and shape. It doesn't get any bigger, it doesn't get any smaller, the angles don't change. It stays exactly the same, it just moved in some way. In a translation, the object also keeps the same orientation. So it literally just slid to another spot. It didn't turn, it didn't flip, it didn't get any bigger, it didn't get any smaller. Again, two words that you need to know, pre-image and image. Pre-image is the original figure, and then image is the transformed figure. Frankly, I don't know why they don't call it the image and the post-image, but that's just me. So here is one example of translating. So my original figure, my pre-image is here in the white, and then my translated figure is shaded in. So here the translation rule was -2, -5. Again, this is referring to x and y coordinates. So this is the x coordinate, which indicates either left or right. This is the y coordinate, which indicates either up or down. So being that these are both negative, it means I'm going to take each point and translate them 2 units left and 5 units down. And that's exactly what happened. So if I look at point A, I went 1, 2, 1, 2, 3, 4, 5, and there's my A prime. B, 1, 2, 1, 2, 3, 4, 5, and C, 1, 2, 1, 2, 3, 4, 5. So then I'm just writing my new points here, and the translated figure is designated with these little hash marks by the letters just to indicate that it's gone through one transformation. I could also check this mathematically because 3 minus 2 is 1, and 4 minus 5 is -1, and all the points would work the same way. The flip side of that is if you're given a pre-image and an image, the translation's already been done, you have to figure out what the rule is. So for this, the rule was 6, -3. And I just figured that out again by counting. So I'm counting from P to P prime, the translated figure. 1, 2, 3, 4, 5, 6, 1, 2, 3. So again, I went to the right 6, which is positive, and down 3, which is negative. And again, I could do that with all the points to double check. 1, 2, 3, 4, 5, 6, 1, 2, 3. They would all work the same way. I could also, again, kind of check it mathematically. So if I'm looking at point R and then R prime, well, -2 plus 6 is 4, and -2 minus 3 is -5. So again, you could do it with the math, check it with counting, vice versa. Either way should work out. I'm going to flip this over and just give an example of one word problem that was in the book. It was number 19, but I didn't write down the page. It's somewhere there in 9-1. So the problem was you are visiting San Francisco. From your hotel near Union Square, you walk 4 blocks east and 4 blocks north to get to the Wells Fargo History Museum. Then you walk 5 blocks west and 3 blocks north to the Cable Car Barn Museum. Where is the Cable Car Barn Museum in relation to your hotel? So again, this problem really tricks a lot of people because they don't know where to start. But I could start anywhere. I just happened to start at the origin. Because since it's in relation to the hotel, it's just all about moving the units from that spot. So if I start here, the first direction was to walk 4 blocks east, which would be to the right, and 4 blocks north, which would be up, to get to the Wells Fargo Museum. So 1, 2, 3, 4, 1, 2, 3, 4. There I'm at the Wells Fargo Museum. Then I walk 5 blocks west, which would be to the left, and 3 blocks north to the Cable Car Barn Museum. So 1, 2, 3, 4, 5, 1, 2, 3. So there's the Cable Car Barn Museum. The question was asking me, where is that museum in relation to my hotel? So if my hotel is here and the Cable Car Barn Museum is here, I went 1 unit to the left, which would be west, and 1, 2, 3, 4, 5, 6, 7 units up, which would be north. That's why I know that it's 1 block west and 7 blocks north. Okay? Again, the key thing to take away from this problem is it wasn't actually asking for an exact location. It was just asking relative to something else. That's why it didn't matter where I started, and I could just count from there. So again, we're keeping it pretty simple. If you had to do a compound translation of some kind, it just means you would do exactly this. You do one translation first, then follow the next rule, and you just keep on writing down where your coordinate points end up being. So that's 9-1 in a nutshell, and I will move on to 9-2. Bye.